Hey everyone, welcome back. You guys sent in some seriously cool articles about this upcoming mission to the moon,
Oh, yeah.
to the Gruithuisen Domes.
Yeah,
And I gotta say, this is like a full-on lunar mystery, and I am here for it.
absolutely.
We're talking ancient lava flows, but get this, they might be made of something like granite,
Yeah,
that's not what you'd expect to find on the moon.
right. Not at all.
So I've got our lunar expert here to help us break it all down.
Happy to be here.
First of all, what's so weird about finding granite on the moon?
Well, the thing is, on Earth, granite usually forms because of things the moon just doesn't have, like plate tectonics and oceans of water.
Right.
So finding these granite-like formations on the moon kind of throws a wrench in our understanding of how lunar geology works.
It's like a total curveball.
It is, yeah. Like finding, I don't know, a penguin in the Sahara Desert.
Okay, yeah, that's a good one.
Something just doesn't add up.
Totally. So, okay, picture this, right? Okay.
You're on the moon, you stumble across these dome-shaped hills.
Mm-hmm.
How do we even begin to figure out what they're made of?
Yeah, it's a good question.
Like, is there some kind of lunar rock identification kit?
Well, luckily, NASA's sending some pretty incredible tech to crack this case.
Okay, tell me more.
They're teaming up with Firefly Aerospace for this one.
Firefly, yeah. Didn't they already do a couple of missions to the moon?
This is actually Firefly's third mission to the moon.
Wow.
As part of NASA's Commercial Lunar Payload Services program.
Okay, so it's like a lunar rideshare for science experiments.
Pretty much, yeah.
Yeah.
It's all about getting these scientific instruments to the moon efficiently.
I love that. So what kind of high-tech gadgets are we talking about here? I read about something called LVIS.
Ah.
It sounds like straight out of a sci-fi movie.
Well, LVIE, that's the Lunar Vulcan Imaging and Spectroscopy Explorer.
Okay.
It's pretty amazing stuff, actually. Think of it as a 2-for-1 deal, part stationary lab, part mobile explorer.
I like where this is going. It actually has 5 different instruments.
Wow.
2 of them stay on the lander.
Okay.
And then 3 are actually part of a rover.
Hold on.
Yeah.
A rover?
A rover.
We're sending a rover to explore these domes. That's incredible. Like hands-on lunar science.
Exactly. It'll be exploring one of the Gruithuisen Domes,
Yeah.
Up close,
Yeah.
analyzing those rocks and that lunar dust, the regolith, to try to figure out, how these formations even got there.
Wow. And this is going to tell us
Yeah.
about how, planets form, maybe even Earth.
Potentially. It could help us understand the really early days of planet formation, not just the moon, but maybe even planets like Earth. Yeah.
Okay, so this little rover on the moon could tell us how our planet formed.
It's amazing. Right?
Talk about a deep dive. But, okay, hold on. Before we get ahead of ourselves, how do we even know what the rover's seeing? Are we getting, a lunar live stream?
Not quite a live stream.
Okay.
But they are sending something called the Heimdall camera system.
Okay.
Basically, imagine a camera that can capture panoramic views from the horizon all the way down to the ground underneath the lander.
Oh.
So we'll have eyes on the ground, literally.
That's so cool. Okay, but what about, getting our hands dirty or, I guess, robotic hands?
Right.
How are they actually going to collect samples from these domes?
That's where sampler comes in.
Sampler.
Yeah.
Okay.
It stands for sample acquisition, morphology filtering, and probing of lunar regolith.
So they just took all the words and made an acronym.
Pretty much.
All right.
But this robotic arm actually has a pretty cool backstory.
Okay, tell me.
It's actually a flight spare from the Mars Exploration Rover project.
Whoa, wait, so it's a veteran space explorer?
Exactly. Talk about recycling.
That's awesome. So what's Sampler going to be doing on this mission?
It's going to be scooping up that lunar regolith, that dust, and sifting it, separating the particles by size like a super precise lunar sieve.
Okay, so Sampler's basically sifting through lunar dust to, look for clues about the moon's past.
Exactly.
I can already picture those scientists back on Earth huddled around their microscopes, piecing together the lunar puzzle.
Absolutely.
Okay, but before we, get too lost in the world of microscopes and regolith,
right,
let's zoom out for a second.
Yeah.
What's the big picture here? Why does this mission even matter?
That's a great question. The Gruithuisen Domes, they're not just a lunar curiosity. They're like a window into the moon's past.
Okay.
By understanding how these, granite-like formations even got there, we're essentially learning how the moon itself has changed and evolved over billions of years.
Okay, so it's about, the whole history of the moon.
It is, yeah. But it goes even deeper than that.
Deeper than the moon. Where are we going with this?
Well, think about it. The moon's like this cosmic time capsule.
Okay.
It's been hit by asteroids, bathed in radiation, but it doesn't have the same kind of geological activity as Earth. It's preserved evidence of early solar system events that we might not be able to find here on Earth.
So by studying the moon, we're kind of looking back in time.
Exactly. Back to the very beginnings of our solar system.
Whoa. So this mission is like opening a time capsule from the dawn of the solar system.
I like that, yeah.
It's amazing. We're not just exploring the moon, we're exploring like our own cosmic origins.
Absolutely.
Now that's something to think about. But hold on a sec, before we get too philosophical here. I know there's more to this mission, right?
Oh, yeah, absolutely.
There are other experiments hitching a ride on that blue ghost lander.
That's right.
So we have LVIS with its rover sampler sifting away, the Heimdall camera giving us those panoramic views. What else are we sending to the moon? Stay tuned. We'll be right back after a quick break to delve into these other exciting experiments.
Sounds good. All right, so we're just about to talk about the other experiments that are going to the moon on this mission.
Yeah, fill us in. What else is joining this lunar party?
Well, first up, we have it's called the Low Frequency Radio Observations Experiment.
Okay.
It's going to be basically listening to the radio waves on the lunar surface.
Radio waves on the moon. Like, what kind of signals are we talking about here? Is E.T. trying to phone home?
No, not aliens, as far as we know.
Okay, good.
But space, it's full of natural radio emissions from the sun, other stars, even distant galaxies.
Right.
And by studying those radio waves on the moon, we can learn about the moon's magnetic field, its interaction with the solar wind.
Okay.
And maybe even uncover clues about its early history.
So it's like we're giving the moon its own radio show, but instead of music, it's all about the cosmos.
Exactly.
I love it. Okay, what's next on our lunar playlist of experiments?
Next up, we have this is a very practical experiment that can really help with future lunar missions.
Oh, okay. I'm intrigued.
It's called the Photovoltaic Investigation on the Lunar Surface.
Okay, that's a mouthful. Break it down for me.
Basically, it's all about solar power, but on the moon.
So, like, they're testing out solar panels on the moon?
Pretty much, yeah. They're testing out some really advanced solar cells in that harsh lunar environment.
Okay. Why is that so important?
Well, if we're thinking about a future where people are living and working on the moon.
Right. Long term.
Yeah, exactly. We're going to need reliable power sources. And what better power source than the sun?
Makes sense.
This experiment is going to help us understand how those solar panels perform with those crazy temperature swings on the moon.
Right, and all that radiation.
Exactly. And that'll help us design, better solar-powered lunar habitats.
Oh, cool.
Maybe even rovers in the future.
So sustainable energy on the moon. That's pretty awesome.
Absolutely. It's all about thinking ahead.
All right. What's the last experiment joining this lunar party?
Last but not least, we have the neutron measurements at the lunar surface experiment.
Okay.
This one's a bit more on the technical side. But it's super important for figuring out the potential risks for long-term missions to the moon.
Risks? Okay, what kind of risks are we talking about?
Well, the moon doesn't have a thick atmosphere like we do here on Earth.
Right.
So it's constantly bombarded by radiation from space.
Yeah, that makes sense.
Including something called neutron radiation.
Okay.
And that kind of radiation can be harmful to humans, especially if they're exposed for a long time.
Right. Yeah, that makes sense.
So this experiment is basically measuring how much of that radiation is hitting the moon.
Got it.
Which helps us figure out how to protect those future astronauts.
Okay, so better spacesuits maybe? Or lunar habitats with extra shielding?
Exactly. The more we understand about that neutron radiation environment on the moon, the better we can design those safety measures for future lunar explorers.
That's really important work, for sure. So we've got these radio waves, we've got solar panels, we've got radiation monitoring. It's like we're setting up a whole research outpost on the moon with this mission.
It's kind of like that, yeah.
Okay, but let's get back to the main attraction.
Okay.
Those Gruithuisen Domes.
Right.
So we were talking about how finding granite on the moon throws a wrench in our understanding of, how it formed. But some scientists think that maybe these domes were formed by ancient meteor impacts.
Right.
So how's this mission going to help us figure out who's right?
That's the big question, right? And that's why this mission is so important.
Yeah.
If these domes are actually volcanic, we'd expect to find certain minerals, certain chemical signatures that are characteristic of volcanic rock.
Right.
But if they were formed by impacts, well, we'd probably see a different set of clues.
Like what?
Well, maybe evidence of shock metamorphism.
Okay.
Or the presence of actual meteoritic material.
So those instruments, LVIS and Sampler,
Yeah.
they're going to be like detectives analyzing those rocks and that regolith.
Exactly.
Looking for those clues to the dome's origin story.
Right. Trying to piece together what happened billions of years ago.
And who knows, maybe they'll even find something completely unexpected.
That's always a possibility in science, right?
That's what makes it so exciting. But I want to talk about the rover for a second.
Yeah, the rover.
We're sending a rover with Mars Rover Heritage to explore a potentially volcanic dome.
Mm-hmm.
It's like we're living in a sci-fi movie.
It's pretty incredible, right?
It is. Imagine those first images coming back from the rover, showing us what those domes really look like up close.
Oh, yeah, like a virtual field trip to the moon.
And not just a field trip.
Right.
Think about what we might find. Evidence of, I don't know, past water activity.
Yeah.
Maybe some rare minerals that could be like super valuable resources for future lunar settlements.
Exactly. Or, who knows, maybe even signs of microbial life. Okay, probably not, but still.
Hey, I'm all for a little scientific speculation, but before we get too carried away, I want to come back to something you mentioned earlier, the Commercial Lunar Payload Services program. This whole partnership with Firefly Aerospace, that's a pretty big deal, right?
It is, yeah. It really shows how important private companies are becoming in space exploration these days.
So it's like NASA's realizing they need help to get to the moon, and these private companies are stepping up.
Absolutely. And it's not just about getting there. It's about doing it in a smarter, more cost-effective way.
Right, right.
By working with these companies, NASA can do more ambitious missions, leading to even more discoveries.
It sounds like a win-win for everyone. And speaking of wins, this mission feels like a win for science already. We're sending all this cool tech to the moon, we're partnering with private companies, and we might totally change how we think about lunar geology. But what does this all mean for us back here on Earth? Like, why should we care about all this stuff happening on the moon?
That's a great question, and it's one we should all be thinking about.
Yeah.
On one level, it's about our natural curiosity, about wanting to understand our cosmic neighbor.
It's about that sense of wonder and exploration that's always been a part of humanity.
Absolutely. But I think it goes even deeper than that.
Deeper? How so?
When we explore the moon, we're not just learning about another world, we're learning about ourselves.
What do you mean?
Well, the moon, it's like a reflection of our own planet's history.
Okay.
It holds clues about how the Earth formed, how the solar system evolved, maybe even how life itself began.
Wow.
So by studying the moon, we're kind of tracing our own cosmic lineage,
So by going out into space, we're actually on a journey of self-discovery?
I think so, yeah. It's a beautiful way to think about it.
It is. But there's also a practical side to all of this, too, right?
Oh, absolutely. As we keep exploring space and think about, maybe having a permanent presence on the moon, understanding lunar geology, it's going to be crucial for things like resource extraction, building habitats, and just surviving long term.
It's like we're laying the groundwork for humans to become a multiplanetary species.
That's exactly.
And the moon is our first stop.
Our stepping stone to the stars, maybe. It really is, yeah. Like we're pioneers, setting out for a new world.
Totally.
Yeah.
But okay, before we get too lost in dreams of lunar cities and moon bases.
Right.
Let's bring it back down to Earth for a minute.
Okay.
This mission, it's actually launching in just a few weeks.
It is, yeah. Crazy to think about.
I know. I'm so excited. But while we wait for those rockets to fire up, let's take a minute to recap everything we've learned about this mission so far.
Sounds good.
Okay, so first of all, we've got these mysterious Gruithuisen Domes, potentially made of something like granite, which is a total puzzle for scientists.
It is, yeah. It goes against a lot of what we thought we knew about the moon.
Totally. And to try to solve this lunar riddle, NASA's sending this whole team of high-tech investigators.
Whole science squad.
Exactly.
Yeah.
So we've got LVISC with its rover, mapping and analyzing those domes up close.
Right, getting all that data.
And then we have Sampler, the veteran space explorer.
Love that. Yeah.
Sifting through that lunar dust, looking for clues about the moon's past.
And hopefully finding some.
And, of course, we've got the Heimdall camera system.
Ah, yes. Can't forget about the views.
Giving us those amazing panoramic shots of the lunar landscape.
Got to capture those lunar selfies, right?
Exactly. And then on top of all that, we've got those other experiments.
Right.
The low-frequency radio observations, the solar panel tests, and the neutron radiation monitoring.
It's like a whole lunar laboratory up there.
Oh, it's so cool. But this is just the beginning, right?
Oh, absolutely. As we keep exploring the moon,
yeah,
I'm sure we're going to find even more incredible stuff.
Things that could, like, totally change our understanding of space.
Totally. And maybe even our place in it, you know?
Speaking of discoveries, what are you most excited to see from this mission? Like, what surprises do you think might be hiding on those domes?
That's a tough one. I think if I had to pick one thing, I'd have to say I'm really curious about the possibility of finding evidence of past volcanic activity on the moon.
Oh, yeah.
You know, if those domes actually are volcanic, it would change everything about how we think the moon evolved.
It would mean the moon was once a much more active place.
Yeah, a lot more dynamic than we thought.
That would be huge. What about you? What are you most curious about?
I'm really interested to see what Sampler finds in that lunar regolith.
Yeah.
Who knows what kind of secrets are hidden in that dust? Maybe evidence of ancient impacts, traces of water ice, or even, you know, maybe some really basic organic molecules, the building blocks of life.
Wow. Now that would be incredible.
They would, wouldn't it?
It feels like we're on the verge of this, like, whole new era of lunar exploration.
Yeah, I think you're right.
I can't wait to see what happens.
Either. It's going to be amazing.
Well, I think that about wraps up our deep dive into the mysteries of the Gruithuisen Domes.
I've had a great time talking about all this with you.
Me too. And a big thank you to all of you out there listening. We hope you enjoyed this deep dive into lunar exploration.
And keep looking up at that night sky. You never know what you might see.
And keep sending us your questions. We love hearing from you.
Until next time.
Keep exploring.